Seng. हाँ हाँ Do it for a few more minutes for the rest to come. All right, good morning, everyone. Welcome to BSc 123 Calculus 2. So first of all, are you all AIT students? Yeah, okay, good. So my name is Seng. Okay, so you can call me Seng. All right. So my office is A4448 if you want to find me in the office. And anything you can email to me is just my first name dot last name at smu.edu.my. All right. Okay. So in my class, right, I hope you can interact with me. Okay. So if you anything that I said doesn't make sense, you should directly ask me. So you should just say, Kiseng, what do you mean by that? Okay. If I wrote something that you can't see, you just say, can you write it bigger or something like that? Just be frank. Okay. And yeah, anything you don't understand, you should talk to me, because I getting feedback say that I need to like talk about something they don't understand, but they don't tell me what they don't understand. So how do I know, right? So please talk to me, email me if you don't want to talk to me. So anywhere you can find me. You can find me email, Teams, and my office hour. Okay. So um so okay. So there's one thing I want to make clear. So I know that maths is not easy for everyone. So but mm I'm here to show you different phases of maths. Okay. So I'm not trying not to just teach you how to solve question. Okay, because solve question you can just read from the textbook. Textbook already tell you how to solve. So if possible, I try to tell you what are you actually doing. Okay, why are you actually solving? Okay, what are you doing when you're solving the question? Okay. So in my class, very important is you understand every word I say. Okay. And then you go back and do exercises. All right. Okay. If you don't understand, you should talk to me. Okay. Some administrative announcement. So I think a lot of you already entered this folder page. About half of you can see. So I listed some textbook here and suggested readings. So these two textbook will include everything you learn in this course. Okay, and exercises and solution for odd number question. And I also posted the other book, Adams. Okay. And with this, I posted the solution where you can refer to the solution if you cannot solve it. But don't try to just look at the solution. Okay. You will never learn. You can study the solution and then try and forget about it and then do the exercise yourself again. Okay. Otherwise, you won't learn. All right. So that's the OAA checking. Okay. Okay. Checking the lecture. Okay. Okay. So I set up some section here. So this announcement will be for me to make important announcements, so you should check Moodle frequently. Student forum is a place for you if you have any question that you want to address to the other students, and then you can do discussion there. Okay, just feel free to upload any question there. And I have a pre-lecture Q&A section forum here. So if there's any question, concept question, solution question, exercise question that you want me to do in front of the class before the lecture, you can pause it here. Okay, before the lecture. And then I will show it in front of the class. And then I will discuss it. Okay? Make sense? Okay. So the most important thing is this course information document here. So here you will include everything that you need to know for this course. Okay. So unfortunately, we have two 8 o'clock class this semester. So we have to deal with it for 15 weeks. So the course structure is in every hour, we will have 40 minutes lecture about, and then we will spend about 10 minutes doing tutorial. So it's a mixed time. It's not fixed time, okay? So about 10 minutes I'll let you do some question. And then we have 10-minute breaks. Okay. So for now, my office hour I fixed at Thursday 10 to 12 and Fridays 9 to 11. Does it clashes with your timetable or not? You guys check, then let me know down. Does it check like clashes with your timetable? Thursday 10 to 12 and Friday 9 to 11. Is that okay so far? Maybe what? Friday, huh? Okay. So do you have other times or not? Oh, Friday everyone have different schedules. How about the other days? Any other days? Okay, so do you have any free times other than Friday? Afternoon Friday. Afternoon Friday. Okay. Because I need to discuss with another class as well. So I'm teaching the max version of calculus 2, so I need to ask them as well. So you guys only have Friday afternoon free? Any other days? Yeah. I mean, I need to know the choice. Yeah. Monday. Monday whole day free. Afternoon. Okay. Uh, Tuesday. Okay. Wednesday.
Oh, we have class until 1 p.m.
Okay. So Friday afternoon or Monday afternoon. Okay. So I will ask another class first and then I'll decide. All right. Yeah. So um yeah, textbook. We have textbooks, PDF version on the Moodle. Okay, you can recognize that we are not going in sequence, so please make sure find the right reference in your textbook. Okay, we are not going in the sequence of your textbook. And then this course is a triple pass course. That means you need to pass the coursework, pass the midterm, pass the final. Okay, so coursework and midterm together, you need to pass 40%. Then final, you need to pass 40%. And then when you add up total, you need to pass 55%. Okay. So for now, we plan to do 3 in-class quizzes, 1 hour. So one we will do at week 6, week 11, and week 15. So because this is a shared course, so that means there's another program doing Seng BSc 1, 2, 3. So the course structure might change due to the class pace. Okay, so for now we fix like this first. So we will make announcement again when the time close. Okay, so this is just a tentative plan. Okay, we will change it. Depend on the need. So the midterm is quite fixed for now. It's a week 6. Okay, week 6. Sorry, week 9. Yeah, okay. So you need to mark your calendar on week 9. But it's during the class time. Okay. Although we do it in LY3, but it's during the class time. Should be a today. Okay. This timing. 2 hours. And then exam final. Yeah. Okay, but when the time calls, we will make announcement again. So far, any question or not? So far, any question? No? All right. Okay. Uh, so please start working hard by now. So if you can do all the exercises in your textbook, I think you are quite good. You will perform quite good in the exam. So try to do as many exercises as you can. Okay. I already posted those solutions and then you can check the answer yourself. If you don't understand, then you bring it to the class. Right. Are you guys okay with turning the light on? Can you guys see the screen? Okay. Otherwise, I think, including me, I will fall asleep with the color. Okay. All right. So let's start. So before we start, let's do some review of calculus. I want to introduce some objects that we need to use that you have learned before so that we are on the same page. Okay. So the first thing I want to introduce is the real line or the real number. Is the word okay to see? Everyone see the word? Okay. So the real line and the real numbers. So you should think of this real line as a number line. So as suggested as the name. So we have 0, and then we have all sort of number, negative number, positive numbers, and fraction. Okay. Maybe we have irrational number. Right. Okay, rational real. Okay. Yeah, so this is a real line. So far, so good. Yeah, real line. Next is a function. So function from R to R, assign a value in R. Does everyone know this notation here? In, okay. In R, assign an element in R to a unique real number in R. We call it fx. Okay. So I have an x and fx. So in my class, right, don't focus on copying the notes. Okay, I will post the notes afterward. Okay, I will post the note. Uh, I'll post the note straight after the lecture, and then I will post another fine-tuned version one, maybe one day after. Okay. So in class, you just focus whether what I say makes sense or not. Okay. I will also make mistakes, so you just ask me. Okay. Okay, so a function assign x. So okay, so we should have an example here. For example, fx equal to x. Okay. Does anyone know how to graph this fx equal to x? Okay. So I saw some of the gesture from you. So you should have two axes here, x and fx, where you have the straight line. So why is this the straight line? Because when it is f0, you get 0, f1, you get 1, f2, you get 2. So you have these diagonal points. And then you extend to all the fraction part. All right, so far okay? Does anyone left out by the trend already? So far okay? Okay, so good. So we have function, we have a real line. Okay, notice that this functions, okay, there's one thing I want you to observe here. So here is a line, right? Infinite line. Okay, there's also an infinite line here. So really, this function tells you how this real line sit inside the R2 plane. Can you see it? Can you see it? Okay, so far okay. Okay, so a function will tell you how this real line sit inside this R2 plane. Okay, that's one idea I want you to see here. Okay. All right. So maybe we'll start today's lecture. So the 10 metric equation and polar coordinate. So as suggested in this topics here, we have two things to learn. One is parametric equation, one is polar coordinates. So what's a parametric equation? So let's take a 2D plane again. Okay. Maybe call it x and y, two variables. So let's say you have a particle. Okay, you have a particle running uh, in a Brownian motion. So you imagine you have a particle, trace out a curve. So let me draw the curve. So maybe something like this. Okay. Is this a function? Why? Okay, very good. Okay, very good. So this is not a one-to-one. Okay. Yeah, good. Okay, so my logic is very clear. So when I introduce one thing, right, I want to use it in the next part. Okay, so don't disregard whatever I introduce. I will straight away use it in the next part. Okay. For example, I teach you this function here. Next part, I straight away ask you, is this a function or not? Okay. It is not a function because why? Here I say I must have a unique fx for each x. Okay. In this case here, why is it not unique? Because if you look at one x, you have multiple fx. For example, this line here, you have 3fx. So it's not unique. So this thing is not representable by a function. Okay. But we still want to study this curve here. Okay, we call it a curve. So, we call it a curve. So what to do? Okay. So we can introduce another variable. Okay, another dimension. We call it a time dimension. Okay. So along this time dimension, we will have different coordinate. Okay, mostly when I introduce this maths concept, right, I'll use through physics. Okay, so you can think of a particle in times moving in R2. Okay, or you imagine you walking in a classroom or in the university. Okay, so you will come back to this place again, right? Like for example, every week you will come back to this classroom and then you walk away, and then you come back and then you walk away. Okay. Yeah, so we try to trace this path. Okay, so this is a curve in a plane. So let's define this. So a plane curve is a curve that can be defined by a pair of parametric equations. Okay, so what do I mean by parametric equation? So let me highlight this. So the x coordinate is depend on t, and then the y coordinate will be also depend on t. Okay, so we introduce an extra dimension to describe the curve. Okay, does this make sense? I will give you example. Okay, I'll give you example soon. So the time has the starting and the ending. We call it A and B. We start at time A and then stop at time B. Okay. So in this case, what should I write? Sorry, ma. So in this case, so DEF is definition, short form for definition. Yeah. So in this case, the initial point, call it the P, is the point FA and GB. Sorry, FA and GA. Okay, and then the terminal point, maybe call it a Q, is FB and GB. So if I label on this graph here, so if I start here and then end here, so we will start with the function at A and end with a function with B. So here is a initial, here is a terminal. All right, so okay, nothing tricky here. So if you get lost already, you should ask. Okay. Welcome any stupid question. Okay. Okay. So examples. So let's put examples here. So let's look at the curve defined by by this pair of parametric equations. So x equals to ft minus 2t, y equals to t plus 1, and we allow negative infinity t to negative. Okay. All right, so notice here that I put negative infinity and infinity here. Does real line include include infinity or not? Does real line include infinity? Yes or no? No. Okay. So you can never achieve infinity in your real life. Okay. So there's no infinity here. So you must remember that real line doesn't have infinity. It must have some finite number. No matter how far you go, you must have a finite number. Okay. So you can see here that we can never achieve infinity here. There's no equal sign here. Okay, we can never achieve infinity. So, right? No. Okay. So we have this function of t, this function of t, different t. So how do you graph this curve here? Okay. So remember what I did for fx equal to x. Remember what I did? What do I did just now? I check point by point. Okay. So similarly for this, you also can check point by point. Okay. I will go really slow in this lecture so that you know what I mean and then you know what's going on. So what's the variable that control the coordinate? T is the time, okay? So only when the time evolve, the particle move, okay? So when the time evolve, you move, you start walking. Okay? When you start walk, the time ticks. So for example, let's plot a few points like this. Okay, so when t goes to -2, what's x? 8. Okay, good. What's y? -1. Okay. When t equals to -1, what is x? 3. Y? 0. Okay, and then you can complete this table if you like. Does anyone not know how to do substitution here? If you don't know how to do substitution, then this course will be a disaster for you. Okay. Make sure you know how to do substitution. All right. So let's plot this point on the 2D plane again, x and y. Okay. So what point do you have? You have 8 and -1. Okay. Where is 8 and -1? 8 and -1. So something somewhere down here. Right. 8 and -1. 3, 0. So somewhere up here. 3, 0. 0, 1. So maybe somewhere up here. -1, 2. Going to the left and going up. 0, 3. Going up. 3, 4. So it's a 3 here. So 4 is further up. And then 8, 5. So further up here. All right. Okay. So you can try to join these curve together. So from this curve, you can see that it is not a function because for a single x, you have 2y. Make sense? Okay. So this curve is going from where to where? Going to from the bottom to the top because the time is going from negative to positive. Okay, if you regard your time going reverse, then you will be going the other way, which is the time traveling. Anyway, okay. Okay. So, but there's one thing to note here. If you turn this graph around, then it will be a function. Everyone see it? Yeah, so if you change x and y, it is actually a function. Okay. I'll not pursue further, but I want you to see this. Okay. If you write x in terms of y, then it will be a function. Okay. All right. If you don't understand, you should think about it. If still don't understand, you should talk to me. Okay, good. Okay, next. So look at the second example here. Let's look at a curve defined by x is equal to cos t and y equals to sine t. Okay, this example is pretty crucial because later on we will move into polar coordinate. So this change of variable is very important for this class here. Okay, let's look at what this curve defines. So what's the time here? So there's a limit for this time. There's only from 0 to 2 pi. Okay, it's not infinity anymore. So how to plot this curve here? It's a circle. Okay, how did you see it? Nice square. Okay, good. Okay, semicircle. Okay, wait, let me let me write down. Okay, so okay, very good. Some of you realize that we have a trigonometry identity, which is cos square t plus sine square t equals to 1. Okay, so these identities, right? These integral identities, right? If you can't remember, you should make a list. Okay, make a list. I think the textbook I gave you have a list in front of their cover, something like that. So download that list, keep that list beside you when you do exercises. Okay, I don't how to say, I don't force you to memorize. Okay, so make sure you know how to use them, where to find them. Okay, so what does this mean? This means that these x squared plus y squared satisfy this equation here, x squared plus y squared equal to 1. Okay, so this position here satisfy x squared plus y squared equals to 1. So how to plot this uh, graph here? So this is a circle of radius 1. Okay, so you could draw a circle. Okay, so with a radius 1. So maybe let me draw it here. Okay. One way to see this cos sine and t's sine t is as follow. Okay. So um, So let's see, we have x, y here, right? Okay. So this means what? So this means that the horizontal part is right. So this horizontal part is actually cos t, and the vertical part is sin t, right? So here you have sin t, and then here you have cos t. Okay. So is this cos t and sin t mysterious or not? Is it mysterious? Why appear as a coordinate? What is sine? Yeah, what is sine? What is sine? Uh, I don't know how you remember this, but when I learned this, let's take this angle as t. Okay. So adjacent to t, we'll put an a. Okay, adjacent to t. Opposite to t, we put an o. Okay. And then the longest part, we call it a hypotenuse. Okay. Anyone not know? Okay. So just feel free to stop me if it is too fast. Okay. So what is sine? Sine is opposite over hypotenuse. Okay. And then cos is what? A over h. Okay, good. Okay, good. So what's our hypotenuse in this curve here? What's the hypotenuse here? 1. Okay. So in this case, when h equals to 1, this reduced to just opposite and adjacent. Okay. Which is your y and your x. Okay. Maybe I put a quotation mark here so that differentiate the o and y. There's different meaning for them. Okay. So far, okay. Okay. So you can see that this curve here satisfies this equation. Also satisfy these two parametric equations. Okay. So we provide two ways to describe this curve here. Okay. So one thing I want to note here. And maybe put this. There are potentially two or more ways to describe a curve involving t or not involving t. Okay. So in this case, we have x equals to cos t, y equals to sin t for 0 to 2 pi. And then 2, we got x squared plus y squared equals to 1 for x and y in R. Okay. So you need to be mindful that sometimes you don't need an extra dimension to describe your curve. Right? This is what I want to show you in this example. Maybe you don't need extra dimension. Okay. But sometimes you need. So if you see that, maybe you can ask a question here. Okay. Isn't that you just say that this curve is not a function? You couldn't write it as a function form, right? Why you can write like x squared plus y squared equals to 1. Okay. Actually, x squared plus y squared equals to 1 is not a function. Okay. Because when x is equal to 0, Okay, y can be +1 or -1. Okay, when x is equal to 0, so if you like, let me write more for you. When x equals 0, y squared equals to 1 implies y is equal to +-1. So you can take this both point as your point on x equals 0. Okay, similarly, you can do it for the other point. So this is not a function. So this is not a function. But this is actually an interesting mathematical object, which we call a Riemannian surface. But I won't pursue further, but I want you to know some of these terms. Okay. Right. So far, okay? Everyone understand this curve here? Okay. I think some of you start snoozing already. Okay. Before we take a break, let's do one exercise, okay? So let's do exercise. Find a pair of parametric equation for circle centered at HK with radius. Okay, before you start, so when I lecture, right, I talk. When it is tutorial, I want you to talk. Okay, you can make noise. So can you guys talk to the one that beside you? Introduce yourself now. Yeah. Yeah, anyone behind you, in front you, beside you, I guess. Okay, let's spend 5 minutes discuss with your friends how to solve this question. And then we'll discuss after 5 minutes. Try it. Ready? You want to show us? Okay, good. What's your name? Jiang Hong. Okay. Okay, so how about the rest? Started? You started? Okay. Please don't be discouraged if you don't finish the question, okay? I think when I studied, we never finish tutorial question in time in the class, okay? So the purpose for the tutorial is for you to start, okay? As long as you are still working on it, that's fine, okay? But make sure you are working on it. Okay, so let's discuss this. So find a parametric equation for a circle that's centered at any arbitrary point and radius. Okay. So let's start with a 2D plane again. Okay. So any point you like. Any point you like. You can pick any point you like. Maybe I put here. HK. Okay. And then I draw a circle here. Okay. And the radius is R. Right? The radius is R. Okay. So for example, this point here, this XY here. So what's the how should I say? How far is this point from the radius? How far is this point from the radius? Okay. If we resolve to the XY component here, so if we resolve to the horizontal and the vertical here. Have you guys learned linear algebra? Learn linear algebra? Okay. Okay, maybe I will use some term from linear algebra. Learn subspace, orthogonal projection. Okay. Learn all those. Okay. So I hope you haven't forgot it. I also just taught it last semester. So you know that a line form a subspace, right? If you learn it. Okay. So you need to do the orthogonal projection of this line to this subspace and then find something orthogonal. Okay. So this is the orthogonal projection. Okay. So if you do orthogonal projection, what do you get? So let's label this. What do we use for angle? We used T last time, right? Use T. Okay, let's use T again. So what's this horizontal line here? Okay, this is just what we discussed just now. This triangle here, right? T, A, or H. Okay. So what's this horizontal green line here? Sorry. What's this? What's this length here? Cosine. I believe you are. I write it first. R cosine T. Right? Okay. Hypotenuse times the cosine T. How about the vertical part? R sine T. Okay, good. So can I take these two as my H or not? H and K. No? Why? Can I? Say again? Sorry? It's not from the origin good. So I cannot take. So I cannot take these two numbers here. Okay, let's label this as XY. Okay, because why? Most probably this will be somewhere here. Okay, because yeah, so it will be somewhere here, not here. So what you do is you move your origin to H and K. Okay, so which means you let me write. So you translate. So you translate your X by H which is the center of your circle, and then you translate your y by k. Okay. Right? Okay, so let me ask you a question again. So does this two equation here make sense? Why? You didn't tell me where t live, right? So you need to tell me where this t live, okay? Where t can take values, okay? So you need to tell me where t lives. Only where t lives, then I can sub t in, and then I get x and y. And then I can get this point out. Okay. Why h and k makes sense? Because it is some explicit value already. Okay. This h and k is given. Okay. But t is not. R is given as well. But t is not. So you need to tell me where t lives. Okay. I can also change this to, for example, let me write. I also can change it to t to 3 pi. Okay. So what does this mean? So I start from 0, I move to 2 pi, and then I move another pi. Okay. Right. Okay. Okay. So we can change domain of functions. Okay. So thing okay. Another thing is, can I write this curve in another form? Yeah. So we can write it. So first is this. Second is we can write it as, anyone know, x minus x square plus y minus k square equals to r square. Okay, so to write it in full, okay, r square. So to write it in full, we will take these two equations here. Okay, and then we turn it into x minus x equals to r cos e, y minus k equals to r sin. Okay, so you can see that when I taught this exercise, right, I try not to teach you just method. Okay, maybe some lecturer will just take these two and then minus h minus k and then see that that satisfies some equation. Okay, because method can be developed anywhere. Okay, different people will have different way to solve it, but principle is just one. Okay, so I want you to get the principle. Also because question can change, but principle doesn't change. Okay, if you learn by question, there's one disadvantage is if I change the question, you don't know how to do. Okay, so you must learn the principle. Okay, but also I will in the class I also will teach you some method to start with. From there, you should get the principle, not just the method. Is it clear? Is it clear? Okay. Any questions so far for this part here? No. Let's take a break until 9:05 and then 9:04 we will resume. 9:04.对，这个角还是 sorry 这个角啊？对，你讲的对，应该要是这个角，对，应该要是这个角，对，你说的对，要这个角。但是我觉得都是一样的，same。他们两个等下，一个这样，一个这样。对，你讲的对，要这个角，OK，首先要这个角， 然后为什么他们是等的呢？你给我想一下啊，你给我看一下啊。OK，在这个 quadrant 里面，这两个是一样的，因为
懂了。对，应该还是这个角，还是这个角。
还是这个角。
对，如果是这个角的话，它就
因为如果你在下面再取这个的话，你就要考虑这些加点的问题。
对。
OK，很好，等下我会讲。对，OK，
所以我想问一下，这个 quiz 是线上还是线下？
线下在巴上，
所以它大概是几个题目这个？
我不知道，就是1个小时应该
1小时，然后它题料大概是多少？
不确定，还没有定。对，
就是你以前这个课也没上过。这个
我没有，我是第三。对。
The R power 2, you can set like cos power 2t and then plus sin power t.
Correct.
Yeah. So
Wait. So what are you doing? So I think should be R, right?
why we need to put the R? Because
because we start with this. So when you minus h, so you still have R cos t.
so we cannot say just x minus h equal to cos t.
Because that one will be just with radius 1. Because we want radius R.
Yeah. Oh, so the radius
Mm.
can be changed. Maybe
Can.
like 2.
Can. So this R means I can put any R. So if I put any R here, will be replaced with any R. So if I put any h and here, this one will be replaced with any h.
Yeah, I just curious because I read the chapter. Why we skip the chapter 11?
Oh, we didn't skip. We just rearranged it.
Oh yeah, why we switch?
I'm not sure because this one is due to the past year.
Oh
Yeah, I'm not sure. I'm not sure.
so we will start with the chapter 10, then go to 12. Yeah. Then go back. Yeah, thank you. Hey,
Can we do solution?
Oh, yeah. Okay, I should mention this again later. Okay, so this. Oh, okay. I mention later. Okay. Oh, I will pass down later. Okay, okay. Testing. Is everyone back yet? Is everyone back yet? Okay. So before we go to the next section, some thing I need to some issue I want to address here. Okay, just now very good. There's one what's your name? No, it's Yang Jiayu. Okay, so Jiayu. Don't make noise. Okay, so Jiayu just now came to me. So why not our T start from here? Right. That's right. Our T should start from here, which is 0. Okay. So 0. Okay. So our domain is something like this, 0 to 2 pi. Okay. But this t here is the same t as this t. Okay, in this case, okay, because you should remember this triangle. What's this? I don't sure what to call this. This is something learned in the high school. So yeah, all science teachers are crazy. So what does it mean by all science teachers are crazy? So this means that every sine, cosine, and tangent, all apply to this angle here, you get positive. And then if you apply sine to this angle here, you get positive. And then tangent to this angle, you get positive. Cos to this tangent, theta, you get positive. And all the other, you get negative in this three quadrant here. Okay, so sine of this is the same as a sine of this, and then they're both positive. Does it make sense? Or a bit confused? Okay. Any question, or you want to repeat? Okay. So in this case here, these two t is the same. Okay. When they are not the same, they are differ by a negative. Okay. All right. What else? Okay. Another thing is you need to keep in mind that when we put this HKR, right, this means we can put any number here. Okay. So we can put R equals to 1, 2, 3, 0.5, and so on. And also we can put HK equal to some maybe 2, 1, 3, 1. Okay, so equal. Okay. So yeah, really, to be precise, I need to say that these points are the point in R2, and this R is in the R. Okay. For those, if you are confused with this variable here. Okay. Yeah, so far okay. So in this course, right, you need to make sure what is number and then what is variable. If you can't differentiate, then you'll be in a mess. Okay. So you need to know what variables are numbers, what variables are real variables, what variables are fixed numbers, what variables are real numbers. Okay. So make sure you can differentiate these things. Okay. Another thing is Raini's, right? Raini's asked about this tutorial question. So actually, if you notice that the lecture note I posted in the Moodle is the previous year one, so they are based on maybe previous edition of the textbook. So the page reference will change. So maybe I will pick a tutorial question from the reference I posted for you, and then you can start from there. Okay. And then if you don't know how to do, refer to Adam's. Okay. Adam's version, we have solution to the question. Okay. There, I can tell you that almost all the calculus have a similar question, similar content. Okay. So although it's not exactly the right question, but maybe they just with some change of variables, change of number. Okay. So yeah. So if we have time, we will discuss the tutorial in the class. If not, then you can ask me, then I will do it in the class. Okay. Yeah, if we have more time, then we can do some extra question. So I'll pass down this attendance list. So try not to sign for your friend. If you cannot make it, you should email me. Okay. Email me personally. Tell me why you can't. Where the list of the exercise? I mean, you mean Oh, just now I already said. So you mean listed in the previous year notes? I couldn't find it. I asked the previous lecturer. Okay, by the way, I'm first time teaching this course, and then the previous lecturers didn't reply me, so I also don't know. I cannot find it as well. So so yeah. So I will assign question from the textbook I posted. Yeah, I will do it after the lecture. Okay, for this time. For future, maybe I will find it earlier. Okay. Yeah. Huh? Can we? Can you? Okay. Good. Actually, you don't need to wait for me. Okay, you can just straight away start and do it because the question is already in there. Okay, but maybe for some of you, you like me to assign, then I will assign. The best way to learn it is to just do as much as you can. Okay, all the exercises are in the textbook already. Okay, any more issue? No more issue? Any more issue? Okay. All right. And also sometimes there's some discrepancy when I deliver the lecture with the previous lecture notes. If I miss some of the question or you want me to address that particular question, you also can request. Okay, because sometimes I feel that is too tedious, then I'll throw it away. Because if I do it in the class, will waste time. Some of it. Okay, if you want me to do it, then anything you want me to do, you can request me. Okay. General principle. All right. Um, 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 maybe. Okay. So for example, I think I will skip one of the questions. Let me see we got this question or not. Okay. I think I will skip this part. Maybe I provide solution later. Okay, I leave this as an exercise. Homework. Okay, rather than exercise, I put homework. Okay, I'll provide this solution here. By the way, can anyone quickly see what is this? Okay, if not this one, maybe this one. Huh? Okay, wait. Good, very good. Semicircle. So how is this semicircle? So let's quickly run through this example. I won't tell you in detail, but at least I tell you how to see it. So if you look at this part here, right? Okay. If the t is running from 0 to 2 pi, I think we already do this quite a few times, right? This is a circle. Good. With radius 1. With center okay, center at 0. Okay. So, but you see, the domain change. Negative pi over 2 to pi over 2. Okay, so pi over 2 is here. So where is negative pi over 2? Down. Okay, opposite. Okay, opposite. So pi over 2 minus pi over 2. I guess some of you may be confused. Eh? Don't you tell me here is 0, pi over 2, pi, and then how should I get here? 3 pi over 2. Okay, why is it minus pi over 2? Okay, because if you go the other direction, you get minus pi over 2. So these two are, I cannot say they are equal, but they are equal to there's some equivalence between them. Okay, so how should I say it? So I want to put a equal sign, but obviously these are not equal because 1 is not equal to 2. So I put one inverted comma here. So they are equivalent up to orientation. Orientation. Too small. Let me move some away. So right, up to orientation. Okay, so the real curve is going from power 2 to minus power 2. So let us remove these things and then just leave with this. Okay. Okay, so your task is to show that why the top equation also describe this curve here. Okay, I already do half of the work for you. What? Right side, right side, right side. Okay, wait. Okay, good. So, okay, the problem with this is going from pi over 2 to minus pi over 2. So if going the other way, then you should pick the other way then. Okay, so you are right. So we should pick this one. Not like a circle anymore. Okay, let me redraw it. You can get it. Okay. So this part is the part you want. Minus pi over 2 to pi over 2. Okay? Yeah. Does it make sense? Oh, you make this one, these two here. So you want to change to what? Is it? You sure? Okay, maybe okay, let me think about it first. Then I'll get back to you again. Okay. So for now is this blue part here. Okay. Okay, I'll leave it like this. Okay. So you suggest that this one is 3 power 2?
Yeah.
Okay. Okay, later we will see. Okay. All right. Okay, so for now, this one left as exercise. Yeah. So make sure you know which circle you're using. I will put it in the lecture note afterward. Okay. So left an exercise. Okay. Let's keep going. So now we want to do calculus on a parametric curve. Right. So what's calculus really? Okay. Yeah, what's calculus? Okay. So some of you suggest that maybe you can see it from the viewpoint of the Chinese translation of calculus, which is differentiation and integration. So what's differentiation and integration? So in differentiation, you are looking at infinitesimal changes. Okay. So you try to zoom the curve as much as you can. Okay, and then see what's going on there. Okay. So one word to summarize this calculus is infinitesimal study. Okay. But I'm an algebra person. So algebra person, we study the structure. Okay. But calculus is the infinite study of objects. Okay. So okay. So now we want to differentiate our curve. We want to differentiate our curve. So you should imagine that we got a curve. Okay. And then now we want to study the tangent over the curve at a point. Okay, at a point let me call it a xy point. Okay, tangent on the xy point. Right. So suppose, yeah, use this short form. Let me introduce this short form. Suppose f and g are differentiable. Does everyone know what is differentiable means? You can differentiate the function, okay? Or f prime, g prime. Okay. So I don't want to go into the detailed definition, but you need to know what is differentiation. Okay. The tangent line. The tangent line. Dy dx. Okay, there's some issue here. What issue? Maybe we fix a name here. Because these are fixed point, so we fix a name for them. So maybe call it x1, y1. Okay. So a tangent line at a point on the plane curve, or we call it a parametric curve. Okay. A point, so let's call this point a name, right? So we already have the name for them, which is x1, y1. So x1, y1 equals to some function of t at the t. And then y1 equals to ft1. So you should imagine that this is a particle, right? And then at time t, I stop at a point. Okay, and then I look at the tangent line. Okay, I fix at a time and then fix a place. I look at the tangent point. Where? Let me see. Why? Let me see. Am I writing this makes sense stuff? Okay, so this curve, so just now we said that a parametric curve is defined by a pair of parametric equation. Okay, so x is equals to f t, and then y is equal to gt. Okay, where y is also a differentiable function of x. Okay, so are you confused here now? I say y equals gt, but then here say again, y is a differentiable function of x. Are you confused? Why? Why is it so? How could it be? Remember that just now we have two description of curves. Okay, we can use time to describe the curve. We also sometimes we can use just x and y to describe the curve. Okay, so in this case here, this is exactly describing those cases when the curve can be just described by x and y. Okay, so this case here is the case we consider just now. So every example is not doing for fun one. Okay, we are building the thing, building the theory. Okay, so yeah, so only those cases we are considering. Okay, so only when y is differentiable with respect to x. Okay, so in this case, what happened? What is dy dx? Anyone have a guess? What's dy dx in this case? Dy over dt over dx over dt. So if okay, don't worry and don't be scared when you see this. Okay, I haven't explained why is this true, so don't be worried. So first of all, actually, when you're writing this dy dx thing, right, it doesn't make sense. Okay, doesn't make sense. So let me write here, remark. When you write dy over dx, what you really mean is differentiate the function y with respect to x. Okay, and what this means is your y is dependent on x. Okay, so this is what you really mean by dy equals to dx. Okay, so this is an operator. You learned linear algebra last sem, right? Okay, huh? No. Okay, this is an operator. This is an function. Okay, so whenever you write d over dx, something here must be a function. So similarly, this is a function in t, this is a function in t, this is a function in x. Okay. Okay. So I still haven't tell you how you get this formula, so I will tell you now. So how do you get this formula here? Chain rule. Okay, good, chain rule. So by chain rule. How to by chain rule? So really you can start with differentiate differentiate yx with respect to t. Okay. Then by chain rule, what do you get? You get differentiate y with respect to dx times differentiate x with respect to time. Okay. Make sense? Then from here, by just rearrangement, you will get dy dx equals to d dt y over dx over dt, which is what you want. Okay. So to excel in this class, right, you need to able to do this switch of variable quickly. Okay. Does everyone following? Are you happy with what we have now? Everyone got it? At least be gentle to that paper. That paper need to stay for 15 weeks. Okay. Need to stay for 15 weeks. Please be gentle to. Is everyone got it? Following? Everyone following? Huh? Any question? Anyone following? Any question or no? No question. Following? Okay. So by chain rule, if you differentiate y in terms of t, then you need to differentiate y with respect to x first, and then differentiate x with respect to t. Yes? Yes, huh? Okay, okay. Okay? So far, okay? Okay? Okay. Okay, maybe let's look at example. How to use this thing here then. Yeah, let's look at example. Okay. Okay, let's look at the curve. Okay. Look at curve y by x equal to 5 cos t, y equals to 4 sine. Okay, one thing you can do before the lecture, right? Please read the previous year notes, okay? So that you get an idea what I'm going to talk. You don't need to understand, but you just see what is going on. And then when you come to the lecture, you have some brief idea what I'm going to say. Okay. Okay. So what's this? What's this curve here? Okay, so let's find dy dx and evaluate it. 6. Okay. Let me think. So I have a brief curve here. Okay. So when I do this kind of question, right, I like to draw some picture. Okay. I like geometry, so I like to draw some picture here. So the picture will be just a sketch, maybe something like this, probably. Not a circle, because you can see that the number here is different. Okay. Maybe it's an eclipse or something like that. So we are looking at t equals to pi over 6. Where is pi over 6? Maybe pi over 6 is somewhere here. Right. So 0, pi over 2. Okay. So maybe it's somewhere here. So let's draw a line here. So we want to find dy dx here. Okay. So far, okay. 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 So you can see that I want to find dy dx, but my y is defined using t. My x is also defined using t. Okay. So how to do? We need to use the chain rule, which is the formula that we established just now. Okay, sorry. So let's take this theorem here, then we try to use it. Okay, so if you already know about this variable, then we just get rid of this variable first. Okay, maybe I keep this variable and then let you see what's the real thing going on. Okay, okay. Okay, oh good. So what? So so from here, can you compute these two things here? Can everyone start computing these two? What is differentiate yt with respect to dt and differentiate xt with respect to dt? Everyone try on your pad. Compute what is dyt and dy dt and dx dt. Okay, anyone get what's dy dt? 4 cos t, right? Okay, how about differentiate 5 cos t? What do you get? Minus 5 sine t. Right. So you differentiate sine t, you get cos t. Differentiate. So let me write not here. So differentiate sine t, you get cos t. Differentiate cos t, you get minus sine t. Okay, these are some important identity you need to memorize. Okay. Okay, so in this case here, what do we have? We have dy dx equals to 4 cos t over minus 5 sine t. Okay, which is minus 4 over 5 cos t over sine. Okay, so far okay. So far, okay. 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 And then evaluate it at t equals to power of 6. Do you know what to do with this? You know what to do with how to evaluate dy dx at time equals to power of 6? So you just substitute t equals to power 6, which is cos t power sine t. Evaluate at t equals to power 6, which is equal to, let me see, so square root 3 over 2 over minus 5. Okay, so also another advice for this course, right? Make sure you have a calculator with you side by side when you do the question. Okay. What is pi over 6? 30 degree. Okay, 30 degree. Let me see. 30 degree. Okay. Again, this is I put equal sign here. Yeah, so be careful with your calculator. Sometimes your calculator is radian. So you need to check. Sometimes it's degree. You need to adjust. Okay. So if you, this one is up to a unit. So here is radian. Here is degree. Let's say you don't bring your calculator, how? If you don't memorize, how? It's compulsory to memorize. Okay. I have a way to reconstruct this whole thing. But you need to remember this triangle here. Okay. So you start with a right angle equilateral triangle here. Okay. And then you can, so we have 30 degree here, 30 degree, and a 30 degree here. Is it just to, okay, yeah, right, correct, sorry. 60, sorry. Divide by 3, right? Because I want 30, so I can remember 30. Okay, but how to get 30? So you just slice this into half. Okay, so you split this part and this part into 1. And you split this into 30 and 30. Okay? So from here you can get your cos and your sine. Right? Cos and sine here. So you can get cos 30 and sine 30 here. Right? So what's this the height of this perpendicular bisector? Root 3. Okay? Root 3, right? Okay. So cos t is adjacent over hypotenuse. So adjacent over hypotenuse. Sine 30 is, hello. Too excited already. Hello. Okay. So sine 30 is opposite over hypotenuse. Okay. So you get these two. All right. So try remember this triangle, and then you can, at least you will have 30 degree, 60 degree. Okay. From this triangle here. Usually the question will evolve around 30 degree or 60 degree or something like that, multiple of them. Unless the lecturer is like a bit pervert. But this is a shared course, I'm not sure. I'm not that pervert. Okay. Okay. What else? What else we want to do? Okay, next. How about we find the second derivative at that point? you just have one information, which is dy dx equals to dy over dt over dx over dt. Okay, I give you this one information here. How you find d square y and dx square. I give you 2 minutes to think about it. So you have only one piece of information. How do you find d square y and dx square? If you want, you can discuss with your friend. Or you only have this one piece of information. How do you find d square y and dx square? Yeah, so how do you find d square y and dx square? Differentiate again? You mean differentiate both sides? Quotient rule. Too advanced, too advanced. Quotient rule. Okay, so let's see what we're going to do. So let's just take y equals to dy dx. Okay. So if we take y equals to dy dx, there's some issue here, right? Okay. How do I change of variable? Okay, I should say apply change of. Okay. So when I say change of variable, right? A can I change something so that we don't contradict ourselves? So let us put w here. Okay, to suit this question here. Is it okay? Is it okay? Okay. So in this case, we will have d dx over dy dx equals to d dt dy dx over dx. Okay, so we just apply a change of variable. We don't need to do quotient rule or differentiate both sides again. Okay, otherwise it will be too troublesome. Okay, so let's put this together here. All right, so let's write it again. So d2y over dx squared is equal to differentiate dy dx again, which is by definition. Okay, this is by definition. The formula we have, or the formula, with this. Okay, so just now we already compute what is dy dx, right? Okay, so we just use it. So put this b case d dt. We also compute ds dt, right? Okay, so where is ds dt? Ds dt here. Okay, copy and then paste. Okay, so I got these two. How to differentiate this? How to do this differentiation? How to do? Substitution. Why not just use quotient rule? How to do substitution? Tangent also can, but you need to know how to differentiate cotangent. Okay, unless you, if you know that formula, then you can use that. Usually we just memorize what is different. I mean, for me, just know the basic, the differentiate sine and cos. Yeah, if you know how to differentiate cotangent, then you can use cotangent. Yeah. Or if exam count have cotangent, because tangent by okay, let me write. Huh? So yeah. So okay. So yeah. So everything can be reduced to sine and cos. So you don't need to memorize what is tangent, what is cotangent. Yeah. But if you happen to know it, then okay, good. Okay. Otherwise, use this definition, sine and cos. Okay. In fact, we will learn a chapter which is for a series. Everything can be expressed in terms of sine and cos. I mean, any function. Okay. So should we do it or should I just give you the answer? Just answer. Anyone want me to do quotient rule or not? Do quotient rule. Okay. I'll do once in the class. Okay. Okay, let's do quotient rule. What's quotient rule here? Okay, let's put this, let's write down the quotient rule. I mean, just an exercise for you to recall. Are you guys familiar with this notation here, prime? Yes? If not, I can explain. Yes, okay. So prime is also, you can imagine another dy dx, but I just don't want to like repeat dy dx, dy dx, dy dx. Okay. So I put a prime. Okay. So maybe I put a notation here. So if I put a wx prime, I mean dwx over dx. Okay. Okay. So I explain this notation here. Okay. So what to do? So what I do is I take my v. So okay. Okay, to make it really explicit here, I'm differentiating cos t and sin t over sin t. So differentiation, right? I can pull any constant up. Okay, that's what I mean by operation, linear operation. You can take the scalar part up. Okay, and then I do differentiation on this portion. So what is my u and v in this case? My u, sorry, this I'm a bit, I'm a bit crazy here. This is product rule, so should be like this. Okay, that make more sense. Okay, so my u is cos t, and then v is sin t. What is u prime? Minus sin t, and then v prime is cos t. All right, so far okay. So we get every term we want other than v square. So v square should be, maybe I just put a v square here. So v square is sine square v. Okay, so let's put everything in place. So first term, what should I put in the numerator to test whether you know what I'm doing? Sin t multiplied by what? Negative sin t, good. Minus cosine t multiplied by cosine t over and square t. Okay, so for tangent, right, usually the practice of putting power is above sign, or you want to put cos t bracket square also can. Okay. So what do we get? So we get minus sine square t minus cos square t over sine square t. So what's this? What is sine minus sine square t minus cos square t? What's that? It is -1. So remember again, trigonometry identity. So this thing appear, I think, second time already in our lecture today. So this is equal to 1. So if you multiply minus everywhere, you get -1. Okay? So you get -1 over sine square t. So altogether, what do you get? You get minus 4 over 25 sine cube. Okay, so this is what you want. So far, okay? Okay. Okay. So maybe in future I will skip this step already. But this is the first lecture, so let's do as explicit as we can. So, okay. This is for the second derivative. The next part we want to evaluate at t equals to pi over 6. So similarly, we need to sub at t equals to pi over 6, which is equal to minus 4 over 25 sine 1 over 2 cube. Sorry, pi over 2 pi over 6 cube. Okay, so if you still remember our triangle here, you can use calculator. I mean, this, if you don't want to use calculator, then you can because I can tell you calculator if you press wrong then your answer is wrong. That's the part that I don't like about calculator. Okay, yeah, if you press wrong, then your answer is wrong. Yeah. Okay, you can use calculator. So what do you get for sine pi over 6? So it's 1 over 2. Okay, so in the end you'll get something 32 over 25. Okay, so one thing be aware of calculator is don't press wrong. Okay, so far okay, everyone? So far okay. Okay, so what do we learn from these two examples? So you need to know how to use formula, okay, regarding the chain rule, and then you can compute out to second derivative. Okay. Evaluation should be easy. Okay, what time is it? Okay, maybe let's take a break. Again, you're not tired, is it? Yeah. Okay, let's take another 10 minutes break until 10:04. Okay. Okay. Very responsive. Where's the attendance list? Everyone signed already? Where's the attendance list? Has everyone signed the attendance? Everyone signed attendance already? Yeah. Please move. Okay. Yep. I can, but I mean, whether
Whatever.
yeah, whatever.
Like this one, I've mentioned that. Yeah, I get your point. Being the virtue, then square to the
Yeah.
negative. But I think that's not the more suitable way to express the interval. I mean, the interval shows the negative point on the left side and the positive point on the right side. Yes. So I think the that
Oh, I get what you mean.
3 over 2. Yeah, that should be 3 over 2.
I got you.
Okay.
Okay, you just mean that the interval need to be increasing, right?
Yes.
Okay.
Oh,
Okay.
okay.
Thank you.
No, no, no.
Thank you.
这个方程的概念，
对
还是就是不太理解，就是因为
，OK，看回那个 example，因为我不然看我的，来看这个，你是说为什么有这种情况，还是
就是因为方程不应该是那种 one to one 的吗？就是它如果不能 pass 那个 vertical line test
我
的话，
觉得你说的很对，它的用词有点怪。
又怎么能说是方程呢？
我觉得你说的很对，我觉得你说的很对。首先，等一下我觉得你说的很对，它应该不可以用方程，它应该用其他词。OK，我觉得你用的很对，等一下我会解决这个 concept 的问题，
哦
等一下我帮你解决这个 concept 的问题
它的其实应该怎么说？
啊。
它其实应该怎么说？
我可以让它变成一个方程，
让它变成方程。
就是我可以 restrict 我的 domain，它就变成一个方程。
但是感觉这个点它很显然还是就
没有啊，我就 restrict 它
哦，
我不要看这些东西，那我还可以做 differentiation。
所以说不是 restrict x，而是 restrict 这个 y 咯。然后还有刚刚就是这一块，其实我没有跟上。
OK，
因为它怎么这些？因为我可能就是已经忘了那个
can root。
对，
OK，
基本上
好，这样从 can root 开始哦，从这一个开始哦，所以这个你完全不知道是
不是，就是基本上已经没什
忘了
么印象了，没来得及。
所以其实就是如果你没有印象的话，先不知道为什么它是对的，就是OK，一开始你有一个 y in terms of x，OK，但是如果你 differentiate with respect to time 的话，你看没有 t 在这里，OK，所以你怎么办呢？第一，你要 differentiate y with respect to x 先，然后那个 t 呢可能是藏在 x 里面，所以你要 differentiate x with respect to t。
对，他们是个 composition。
can rule 就是对，就是 composition，对，没错，OK，你讲的对，所以这个就是 differentiate，这样子，这个它是其实是这个，然后从这边开始你就可以拿到你要的这个咯。对，没有错，就是这个东西，没有错，differentiate，这个东西，对，就是这个东西。
那我理解。
对，
然后这个笔记是下课就会传上四楼吗？
我在那个黑板写的东西，我先传上去，不管对还是错，我都传上去先，然后我会改一份对的完整的之后再放上去。
OK，
呀
好。然后还有那个
如果有错，你就发邮件告诉我。
还有那个 exercise 的话，我是看他那个
对 exercise 的话，因为他的那个是不知道哪一本书挖出来的，但是它的题型是类似的，所以如果你要跟着那个数字去做的话，也没有什么关系。但是为了 standardize 之后我会发一个正式的，在这个 lecture note 里面，然后就跟着我现在发的版本。
好的 OK，
OK，
谢老师。
看一下上面
上面哪里上面？
就是知道上面。为什么是 dydx？
因为你看，那 formula 是这样嘛，对不对？所以假设我把这个 w 呢变成 dydx 呢，我就会取到我想要的东西。
它不是 d 平方 y 不是修到2次？
对，这个东西是什么？这东西其实是 d dx d dx 这个 y。 这个的定义。
哦，
Yeah,
是下面这个 x 方求到上面这个 y 两次，我以为是 d 求到那个 y 两次。
这个是 dydx 这个东西是等于这个吗？但是我是这样子 dydt 乘以这个 dtdx 嘛，因为这个把它分开嘛，嵌入嘛，不是？
我觉得等一下你给我看看，我觉得你等一下我看看，你可以这样做，然后
这个又不是这个
不是这个，所以你这一个是我们第一次算的那个 dydt 哦，然后 dtdx 的话要怎么算呢？你要把这个 t express 成 x 了过后 differentiate 哦。
expression 是 x
就是所以你要
你把它倒反了，你 differentiate 倒反来也可以，是就是 one over
等于吗？好像等于
啊，
好像等于。
你这个这么是这个
这
个 cos 这个 cosecant square
什么意思？什么意思？
你没有算错啊？因为 x cotangent 这个对哦，这么你这个是上面这个是哪 cotangent 的 ？cotangent 是这个吗
OK， 好，这个 cotangent 没问题。
这么是哪 dydx 的这个？
听不懂你问什么？
它这个应该是这个嘛？那 dydx 这个 dydt 的不是？
因为你是用另外一个方向来嘛，我是从另外一个方向嘛，里面。I mean，我们两个用的东西都不一样，你是 dydt 哦，我是 dydx 哦，我们用不一样的东西。为什么 dydx 跟 dydt 要？
我这个方法也会拿回这个的。
我觉得你最尾是一样啦，你中间不一样。你可以试下这个下去看一下。
但是你这个是怎么样怎么样？
我要 prove 出来就是我把这个 w， 你看这个 w 是一个 function 嘛，我这个也是一个 function 嘛。那
你放到一个 variable 啊？是什么？这个 w 又哪里来
？OK， 这个 w 哪里来？之前是 dy 嘛，对不对？它只是一个 variable， 我可以放 d w d z d 各种各样的东西啦。但是我把这个 w sub 成我这个新的 function 叫 dydx。sub 了，然后就这样就 sub 了，然后其他东西都会 stay 咯。最主要的变化就是这个 w 的 part 哦，可以吗？因为重点是这一个 part 是什么？这个 part 是我要的东西嘛，这个是 formula 给的东西，或者那个 definition 给。
大概
你可以用你的方法，你算一下应该要得到这个。
它是要我们 prove 什么？是 prove 这两个是等于还是这两个是等于？
这两个是等于。两个一起才可以 define 一个 parametric curve。
我以为那就奇怪，奇怪怎么是这样子？
你的点有 x y 嘛，所以你两个都要告诉我怎么选。Hello, testing. Okay, good. There's one student asked me about this conceptual question here. Okay, I didn't explain just now. I'm not trying to hide it, but this here says that y is also a differentiable function of x, right? So from what we see just now, okay, let me remind you the example we have just now. For example, we have the square thing, right? So it's a circle. So although this is differentiable, but it is not quite a function, right? Okay. So if you read the textbook, you will see the vertical test. Okay, it's exactly what we say. One point cannot have multiple point on F. So what to do? How to make it a function? Yeah, how to make this thing into a function? But in this case, if you interchange, you still get a whole circle. Okay. So how? Fin. Okay. So what you can do is you restrict your domain or your codomain. Okay. So if you restrict your codomain, to above here, just looking at the top part, it is a function. Or just look at the bottom part, it is a function. Okay. So when I say, so in the first part, I mentioned about a word called Riemannian surface, right? So Riemannian surface is something like this. So you use two functions to click to find this surface. Yeah. So in this circle here, right, you can break it into a upper half semicircle or the lower. Okay. Of course, yeah, upper or lower. Okay. So in a general, how about this curve here? So you can see that here you have multiple f here. So you can restrict your codomain to, for example, this part. And then you do your differentiation. Or if you want to find tangent here, then you restrict it. Then it is a function again. Okay, so you restrict your domain or codomain. Okay. So far, okay. Yeah. All right. Okay, good. Okay, good. Okay, next. So next, we're gonna do something more interesting. So why we find this tangent thingy? Okay. So let's do some interesting example here. So let's look at another curve. Define a curve defined by s equals to t squared, y equals to t cubed minus 3t. Okay. So this means that in x direction, you are square. The speed is like square the time. Okay. So the speed is like square the time. And then in the y direction, the speed is like 3 cubed minus 3t. Okay. So let's show that C has two tangent the point. Okay. And then and find the equation. Okay. So we want to find tangent, right? So we have formula, right, just now. Okay. So what's the formula? Anyone can recall? dy dx equal to dt over dx dt. Okay. So this means you need to find me dy dt and dx dt first. Okay. So what is dy dt in this case? dt square minus 3. ds dt is what? 2t. Okay. So in this case, dy dx is equal to the, what do you get? 3t squared minus 3 over 2t. Okay, so this is our dy dx. Have I told you the meaning of dy dx yet? I think that I haven't tell you what's the definition. Let me see. Okay. Okay. Sorry, here. So, okay. Actually, that time you should ask me here already. Tangent. Have I spell this word correctly? Okay. So this tangent line, right? Line is a line, right? So dy dx is a function of formula. Okay. Let me see. Let me see if I write it properly. Okay. this is a line. Let me see. How should I fix it? How should I fix this? Okay. So really, this word here is this sentence here is not complete. Okay. So dy dx is a function. Okay. So tangent line is a line. So how is it this line combined with this function here? Okay. So this line here is not complete. Okay. So how do I complete this? So I should say, okay, maybe let us move this part up also. Let us keep this this formula in mind. Okay, so what I should say is with gradient dy dx evaluated at xy. Okay, don't worry about what I write first. Later I will show you what is it. Okay, but just yeah, it's a tangent. The tangent line with gradient. This. Gradient is y equal y minus y1 equals to dy dx. I think I'm right. Let me write down first. Okay. Don't worry, you don't understand this part, but I will show it in the example. Okay. So what I written here is really, if you find dy dx and evaluate at this point here, that is the gradient of this line. Okay. Tangent line is always a straight line. So straight line has a form. So let me write. So it's y equals to mx plus c. Okay. Straight line is always y equals to mx plus c. And then what I claim here, okay, this is the part you need to know. So m here is the dy dy dx. Right. So dy dx equals to m, in other words. Make sense of? If y is equal to mx plus c, you differentiate y with respect to x, you get m. Okay. So this is the m we find at that point x, y. Anyone lost? Lost? I'll show you in an example. Okay. So what do I mean is dy dx is the gradient of that at that point. Okay. Okay. So this is the confusion of this course here. Okay. So sometimes we talk about t, sometimes we talk about xy. Okay. So you need to be able to translate between point and t. Okay. So you are at a point, you need to know when you reach it. Okay. You need to find the t when you reach that point. Okay. So for example, you are giving this curve here. I'm not sure how to draw it yet, but it tells you that you pass through 3, 0. Okay. So you need to find what time you pass through this position. Okay. So let's find the t where when we pass through it. So when when x equals to 3, t squared equals to, okay, let me write out in full, since s equals to t squared, then 3 equals to t squared. So that means t equals to plus minus square root 3. Okay. So far, still okay. Okay, and then when y equals to 0, then t cubed minus 3t equals 0, which means t times t squared minus 3 is 0. So what's the root of this polynomial? T is equal to 0, and then t is equal to plus minus 3, 2. But you want both of these to hold at the same time. So how many times you have? Just 2, okay? So since xy equals to 3, 0, we have t equals to plus minus square root 3. Okay, so that means at these 2 times, your curve will pass through 3, 0. Okay. But how about this t equals 0 here? When t equals 0, y equals 0. But what about x? X is also equal to 0. So it passed through 0, 0 instead of 3, 0. Okay. Okay, good. So we have these 2 points here. Okay. So we already get these 2 points here. So let me summarize what we have. Hence, when t equals to plus minus 3, we have xy equals to 3, 0. Okay. So now we want to find the gradient at t equals to plus minus 3 or at the position 3, 0. Okay. So let me draw some local graph here. So maybe 3, 0 is here, 3, 0 somewhere here. Okay. At time equals to plus minus. Okay. We don't know what is going on, but we want to find a gradient here. Okay. So this one is just a sketch. Okay. So let's copy what is dy dx we found just now. Okay. So we want to find dy dx on these 2 points. So at t equals to square root 3, what do you get? Can anyone press calculator or calculate quickly? What is this? What's this? Root 3. Good. How about at t equals to minus root 3? Negative root 3. Okay. So okay. Okay. So that means at these 2 points here, so we pass through these 2 points twice. So I don't know how to draw. Maybe because this is one is root, one is a positive, one is negative, right? So we should change this curve here. So the first one should be a negative one. So we have something like this and something like this. Okay, so maybe going from here and then maybe something like this. Okay. So how to write the tangent line? Okay. So let me write. Here is t equals to square root 3. Here is t equals to root 3. Okay. So let me see how to show it. Okay. So at t equals to root 3, what do we have? So we have y minus y1. Let us put the formula down first. Equals to m at the square root 3 and then x minus. Does anyone have a question on this formula here, this straight line formula? No? This one is presumably you know from previous. Okay, if not, I can explain now. Okay, so what's this? So from what we discussed just now, this is really dy dx at t equals to square root 3 x minus x1. Okay, and then y1 x1 is a point that is on the line. So there's an obvious point that you know. 3, 0. Okay. So pass through tangent line. Tangent line passing through 3, 0. Okay. So we sub everything we know. We know the point x1, y1. We also know the gradient from what we found just now. So we just plug everything in. So minus 0 equals to what we get? Square root 3 x minus 3. So we get y equals to square root 3 times x minus 3. Okay, so far okay. And then similarly, you can do it for t equals to square root minus 3. So it also passed through the same point, so we still have the same point. But in this case, what is our gradient? Our gradient is minus root 3. So y is equal to, okay. So let us move this sketch down. So we have a description for our tangent line. Okay. So we have a y equals to square root 3 x minus 3, and then y equals to square root 3 x minus 3. So far, okay? Okay. Yep. Oh, both have to intersect at 0. Okay, very good. So that's mean, right? So what do you mean by that? So, okay, correct. You are right. So there's so okay, let me see. So correct. You are right. So actually, I split the time up. So the okay, let me make it bigger so that we can draw. Correct. They are at the same point, but I kind of like split the time up, so it's like expanding the space. Okay, so let me move this. Okay, this one actually can throw away. So we actually pass through these twice. So maybe something like, I don't know what's the real picture. I just simply draw. So I just go up here and then maybe come back again. Something like that. I don't know the whole picture yet. I just simply draw. Okay, simply draw yet. Because we were going to find this picture based on what we found for our tangent. Okay, so far we only found 2 tangent lines. Okay, we need to find more. Okay, so just keep finding and then we will see what's the whole path here. Okay, next part. So next part, find. Actually, if you be more careful, you can find what's the x-y intercept and x-intercept, and then you will know that what point you have to pass the axis. But for now, I didn't do that, so we just guess. Okay, simply guess. So next, let's find points on C where the tangent is horizontal or vertical. Okay. So if the tangent is horizontal, right? So this means in the y direction, there's no change. Okay. So this means dy dt is 0. If it is vertical, that means you only change in the x direction. So y, wait, what am I talking about? So if vertical, okay, let me write down. Repeating myself. Let me write down. So horizontal tangent. Okay, so for horizontal tangent, first of all, dy dx is 0. Okay, because you want to find the tangent. And then horizontal means dy dt equals 0. Okay, but dx dt is not equal to 0. Okay, so what is this doing is you should imagine something like this and then this. Okay, horizontal tangent. So dy dt is 0 and then ds dt is not 0. And then for vertical, the other condition happen. Dy dx is 0, but dt dy dt non-zero, dx dt is 0. Okay, so you should imagine something like this, and then the vertical. Okay. Okay. Okay, so from here you try and find where do we get this? Do we have horizontal or vertical tangent? So far, okay. So horizontal tangent, the y direction don't change. Okay, so you're not going up anymore. You're just only going left, right. But for vertical, the x doesn't change. Okay, so you're going up. So far, okay. 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 So let's see what this equation give us. Okay. In particular, this one, dy dt equals 0. So we already compute dy dt, right? So what's dy dt? So let's get. So you can see that this calculation, right, can be used for different subsequent question. So make sure you don't calculate wrong, otherwise you will have cumulative error coming up. For me, I won't take marks from cumulative answer, but this is a share course, so have to be aware of another lecturer. So make sure you do everything right. Okay, this is a lesson I learned. Because some lecture they just take off mark if it's wrong answer in the end. Actually, the step is correct, but for me, I will give the for the step. Okay, so let's make this equal 0. Okay. Okay, what do you get? You get 3t squared minus 3 equals 0, which is t equals to plus minus 1. Plus minus 1, right? Because it's t squared. Okay, okay, good. So that means at time plus minus 1, you have this horizontal, vertical. How about the vertical one? Vertical tangent. Oh, okay, good. So 2t equals 0 means t equals to 0. Okay, are we enough now? So what do we have now? Okay, where is this point actually? So we already know the time, right? Okay, but we not yet know where's the position. Okay, so when t, bless you. So when t equals to 1, what do you get? What do you get? When t equals to 1, what do you get? Okay, let me copy the. Can anyone remind me what is x? What is x? T squared, good. Is it? T squared, okay, good. So what is y? T cubed minus 3t. Wait, let me move these guys. T cubed minus 3t. Okay. Actually, I also can integrate from here. So what's the point at time equals 1? You get 1 and 1 and what? Minus 2. Okay. How about t when t equals to minus 1? What do you get? 1 and 2. Good. Okay. So how about when t equals 0? What do you get? Good. 0, 0. Okay. 0, 0. Okay. Okay. So what do we have? So let's collect what we have now. Let's do the picture again. So let's sketch again. So what do we have? Okay. So from part A, we know that at 3, 0, we have two tangent line. Okay. One is the square root 3. So I put square root 3 as the m1. And then square root 2. And then minus square root 3. All right. Then we have horizontal vertical tangent at 1, 2, and 1 minus 2. Okay. So 1, 1, 2. Where's 1, 2? Maybe somewhere up here. Okay, let me. How about make this smaller? Okay, we have 2 minus 2. So we have a horizontal here. And then the horizontal here. How about vertical at 0, 0? So we have a 0, 0 here. So just put a 0. Still hard to imagine? I don't think so. Let us try. Okay, so there's an obvious curve that you can draw. I mean, I don't say that it's correct, but it's an obvious one. Okay. So what do I mean by that? Let's plot the time as well. So this time is 0. Where's the time? This is a minus. Sorry, this is a plus 1 time. This is a plus minus 1 time. And then what's the time for square root 3? So you can see that when time is minus square root 3, the gradient is minus square root 3. Okay. So here is the time is square root 3. Here is time is square root 3. Okay. So that means what? The curve go from minus square root 3 to minus 1 to 0 to 1 to square root 3. There's one obvious curve you can draw. Okay. Might not be a correct, my obvious one. Okay. So we need to follow the timing and then follow the tangent and then we make the turn and then too ugly. Okay. Okay, so how to prove this one is the correct one? Next part. How to see this is actually a correct one? So we need to determine. So we need to determine where the curve. Where the curve. Change this. Yeah, determine where. Determine where the curve is concave, upward or downward. Okay. Okay. So do you still remember how to check this thing? Tangent is increasing. Okay, wait. So concave, not the tangent, but the second derivative. Okay. If it is concave up, then the second derivative is greater than 0. If concave down, the second derivative is less than 0. This one is from last semester, I think. Okay, if you don't remember, you just remember these two is enough. So that means we need to compute what is the second derivative of y. Okay, which we learned just now. Okay, so it's d over dt over dy over dx. Okay, so we try to put everything we learned together. Anyone still remember what is dy dx? Dy dt? Dy dx, sorry. What's dy dx again? This guy. So the most important thing for this course is you know what you are computing, because the expression will get as ugly as it is. So make sure you know what you are computing, then you won't be wrong. What's ds dt? Copy back. But I can promise you that the answer is always beautiful. Okay. So how to compute this? Huh? Okay, I think there's an easier way to compute this. So 3 over T2 over 3 over 2. Right? Okay. So you differentiate difference, you can split the differentiation. Okay, you split the differentiation, then you just differentiate the polynomial. Okay, so what do you get? Quick exercise. What do you get? 3 over 2 minus minus what? Minus 1, 3 over 2, 2t squared. Okay, is it? Everyone following? Anyone following? Following? Okay. So what do we get? We get 3 over 4. 1 plus 1 over t squared over t. Okay, so to make this nicer, you could multiply t squared at the top and bottom, where you get t squared plus 1 over 4t. So if you like, I'm actually multiplying t squared so that I do nothing to the fraction. Okay. Okay, so come back to the question. When is it? So when? So let us remind ourselves what is this value here. So this is d2y dx squared. Okay, so the question is when d2y dx squared is greater than 0, and when d2y dx squared is less than 0. Okay, can you spend 2 minutes and think when? When is this expression greater than 0? Yeah. T greater than 0. Okay, so you can see that the numerator is always greater than 0. Okay, because square of any number is positive, and then add positive number, multiply positive number is still positive. So the thing that control the positivity of this number is the denominator. Okay, so the way to get negative here is when t is negative. Okay, so this means that, okay, let me get it down. So when d squared y dx squared is greater than 0, then t is greater than 0. Since t is always positive. similarly implies t is less than 0. Okay. So when t is greater than 0, it concave out. Okay. So concave out, what does it mean? So I think something like this. Okay. Concave down, something like this. Okay. So if you put these basic shape together, I think if you also check all the intersection point, you will see that this is actually the curve. So when the time is less than 0, it is concave down. Okay, so you concave down, and then when time, okay, when this is the time changing from 0. So when the time is positive, it concave up. There's only 2 points it will make this change. Okay, so concave down, and then after 0, after the point 0, it concave up. Okay, so this is the curve we're looking at. Okay, so far so good. Yeah. Wait, let me see. Tangent line supposed to be equals to infinity. Wait. No, I put the time. I label the time. Huh? Oh, dy also. Wait. Let me see. Correct. Correct. Is it? Let me think. Oh yeah. Correct. Correct. Yeah. So yeah. The way you think of it is like the dy dx, right? So if horizontal is 0, so if you increase like this, so it go positive and then getting more positive and then yeah. Okay. Any question? Correct. Yes, that's right. So so infinity in real number, actually it is a problem. So what do you mean by you don't need to use it, so you are not using it for calculation, so that's fine. You are not using for calculation. To find the tangent, vertical tangent, the main part is ds dt equals 0. Yeah, you are not using dy dx equals 0. So I shouldn't say equal because you cannot reach. So the way to think of it is like you should move this line. Okay. Yeah. Any other question? Any other question? Okay. Okay, before we finish, let's introduce another concept. Okay, before we end, let's talk about arc length. Okay, so arc length means what? You want to measure the length of the curve. Okay, so you want to measure the length of the curve. But how to measure it? Small change. Okay, so the principle is actually coming from Pythagoras theorem. Which is the right angle triangle. C squared equals to A squared equals to B squared. Okay, so you make the triangle around your curve as small as you like so that you can compute the length. Okay, so what's the formula? So let's give the formula. So the arc length L of a plane curve. Plane curve defined by x equals to ft, y equals to gt, for t given a range is, so you integrate, so L a to b square root of dx dt square plus dy dt square. Let me move this around. Dt. Okay, so in this Pythagoras theorem here, so why Pythagoras care about this? So in the Egypt time, right, they need to divide their land. So if you divide the land, right, if you draw one straight line, it's gonna be Malay, we call Seng. If you go a bit away from the 90-degree, then you will get more land, you know. So they want to be accurate. So they use this c square equal to a square plus b square, where c is obtained by square root a square plus b square. Okay, so you can see the similarity here. Okay, so the change in x is the a, change in y is the b. Okay, so why we introduce this integral here is because we want to make this triangle as small as we like. Okay, and then we sum over all. Okay, this is the basis of the integration. Okay, should we do one exercise before we go? Okay, we should do one. Okay, because next part we do polar coordinates. Okay, then we end here. Yeah, let's compute the length of a curve. One curve. Okay, let's compute the semicircle or the semicircle. Semicircle. Okay, first of all, before computing, do you know what's the length of a semicircle? I mean, circle of radius 1, center at 0, 0. Anyone know? R is 1, so R is 1. Pi. Okay, so the length of this curve should be pi. So let's see this formula give us the right answer or not. Okay. So our time is going from 0 to pi. Okay. So what's this formula here? So let's compute this formula. Is so what is ds dt? Can anyone quickly compute? What is ds dt? Today we just deal with these two. dy dt you get cos. Okay, again trigonometric identity. What do you get? You get 1. Okay, what is a and b in our case? 0 and pi. So you are integrating from 0 to pi on 1 dt. Okay, which is equal to t evaluated at 0 and pi, which is pi minus 0, which is okay. Okay. Yeah. So so the circumference of a circle equals to 2 pi r. Okay. So length of semicircle of radius 1 is half time 2 pi times 1, which is pi. Okay. Any question? No? Okay, then we will meet on Thursday, 8 o'clock. Okay. See you again. Yeah. Wait, let me stop this recording.